Now in this video, let me go for the vibration on a string for three consecutive modes. The drawing what you are seeing here in the bottom is showing the vibration formed on a string. The two edges of the strings are fixed. Okay, so edges of the strings are fixed. This vibration is in third mode. This is in third mode. In third mode of vibration. Third mode of vibration. So then, what is the first mode? What is the second mode? What is the third mode? So we need to explain this. In the third mode, we will see three loops. These are the loops what we call, right? So these are the loops. So how many loops I am seeing? I am seeing three modes. Three loops means third mode. Okay, so three loops means third mode. In the second mode, I should definitely get how much? I should get only two loops. And in the first mode, I should get only one loop. That is called the fundamental mode. Let us describe what actually the fundamental mode is. Say I am having a string like the same, what we are seeing in the picture. And if I pluck it in the middle, okay, so in the middle, if I pluck it here, so what I may get? I may get a vibration like this. This is a stationary wave. One wave goes in this direction, and meantime it will get reflected back, and it again comes, and it will meet the initial point again. So this kind of one vibration is what we can call. We can call it as the fundamental mode. Okay. So this one is fundamental mode of vibration. Fundamental mode of vibration. Fundamental mode of vibration. In fundamental mode of vibration, how many loops I am getting? I am getting only one complete loop. Okay, so only one loop is visible. Okay, so one loop is visible. So this is what we call the fundamental mode of vibration. Equivalently, I can also call first mode of vibration. First mode of vibration, which is the fundamental mode. So now you just observe the distance between the initial point and the final point, this one. This is nothing but the distance between two nodes. So I can call node 1 and node 2. The distance between the two nodes is how much? It is lambda by 2. Okay. The corresponding wavelength here we call it lambda 1. I'll write it one more time. Here it is not so clear. Right. So this one is lambda 1 and by 2. So this is the wavelength which is equal to the length of the, right. So lambda by 2 is equal to the length of the string. Say the length of the string is of length L. Okay. So it is L. So in future I am not going to change this length. I am keeping the length fixed. So what happened here? Here the length is equal to lambda 1 by 2, and further I can rewrite it as lambda 1 equal to 2 times L. If you want the frequency of vibration corresponding to the first mode, okay, the frequency of this mode of vibration, mode of vibration, this mode of vibration is what actually it is f1. I call it f1. This is equal to v divided by lambda 1. Why we are writing this? The speed of the traveling wave on a string is transverse, and the transverse wave, the speed of the transverse wave is given by this formula, v equal to f lambda. Now further I can go, that is using, because see here the lambda 1 is 2 times L. I can make use of lambda 1 equal to 2 times L here in the denominator. So which means what? I may get what? I may get f1 is equal to v divided by 2L. Okay. So this is the expression for, the fundamental frequency. Okay. So we call this as the fundamental frequency. Fundamental frequency. Okay. So F1, otherwise the first mode of vibration frequency. Here, believe that the speed of the wave is V equal to F lambda, no doubt, but it is also given by root of T divided by mu, where T is the tension in the string, and what actually this mu is? Mu is mass per unit length, of the string, Okay, so this F1 corresponds the first mode frequency. Let me describe the second mode of vibration. In the second mode of vibration, see what happens. The same wire, same wire, when it is plucked somewhere here, the formation of wave will be like this. So this is the transmitted wave. When it reflects back from this end, it may go like this, and you may see two loops, the formation of two loops. How many nodes I am getting? I am getting node 1 here, node 2 here, and node 3 here. 3 nodes I am seeing. Okay. So in the earlier case, there was only 2 nodes, and in the middle there was only one antinode. But now I am finding 3 nodes, right? And how many antinodes? So this is one antinode, and this is the second antinode. Okay, we will see 2 antinodes and 3 nodes. Now this is, see here, this complete length from N1 to N3 is lambda, complete wavelength. Otherwise, I also can write as lambda 2 by 2. Okay, so 2 times lambda 2 by 2, it is equal to lambda 2, not out, lambda 2. But I am keeping it as it is to do some mathematical work later. This is my second mode of vibration, and here I will see 2 loops. Okay, so this is what? Second mode of vibration. Second mode of vibration. In the second mode of vibration, I am getting how many loops? 2 loops. And the length of the string is still same. I am not altering it, right? So it is still L. Then what I can write? I can write L is equal to 2 times lambda 2 divided by 2. If you go ahead, you can also write lambda 2 is equal to, on making cross multiplication, you will get this one. Lambda 2 is equal to 2 times lambda by, L divided by 2. Again, write the formula for the frequency. Okay, so frequency for the, I am writing here, frequency for this mode, that is second mode of vibration, is F2. So which is equal to, it is V divided by, what it is? V divided by, it is lambda 2. I should not write V1, V2 or something for different modes, because the string is same, and in the string the speed of the wave is still root T divided by mu. We are not altering it. So this is a constant. Until we alter T and mu, that V is constant. So further what I can do for F2? So F2 is equal to V divided by, what I can do? Lambda 2 is 2 times L divided by 2. 2 times L divided by 2. I can modify it. So this is further F2 equal to 2 times V divided by 2L. And observe this bracket. V divided by 2L is here. So V divided by 2L is F1. So what I can write for this? So which implies what? F2 is 2 times F1. So we got the first mode frequency here, and the second mode frequency here, which is 2 times F1. Now we shall bother about the third mode of vibration, where we will see 3 loops. The formation of 3 loops are visible. Again, I am considering the same string whose length is L. whose length is L. I am not altering the length. The length is still L. I will plug somewhere here. So then you will find the formation of 3 loops like this. When the wave is reflected back, it will go like this. It is going like this, and it will come back here again. So now see how many nodes I am getting. I am getting N1, N2, N3, and N4. Okay, so I am getting 4 nodes: A1, A2, A3, 3 antinodes. Right. So now one node to node, the distance node to node is lambda by 2. Okay, right. So one node to another node, the distance is how much? Lambda by 2. Now I'm having how many such differences? So 1 lambda by 2 here, 2 lambda by 2 here for the second loop, and for the third loop it is 3 lambda by 2. Okay, the complete distance becomes 3 times lambda by 2, and the wavelength corresponding to this mode is lambda 3. Lambda 3. That means the total length L is now equal to what? It is 3 times lambda 3 divided by 2. You can proceed to write lambda 3, and lambda 3 becomes what? It is 2 times L divided by 3. 2 times L divided by 3. So this is lambda 3 what I got. The wavelength corresponding to the third vibration. So this is my third mode of vibration. Third mode of vibration. And in the third mode, the frequency is again written as the frequency for this mode. For this mode is F3. So F3 is what? Which is V divided by lambda 3. So now make the substitutions for lambda 3. So F3 is equal to V divided by 2L by 3. Make modification. This is equal to F3 3 times V divided by 2L. Again observe, V divided by 2L is our F1. Right. V divided by 2L is our F1. So I can rewrite this F3 as it is 3 times F1. So now I got some information regarding the frequencies. The fundamental frequency, otherwise first mode frequency, is V divided by 2L, which is here. First mode frequency. And the second mode frequency is F2 equal to 2 times F1. And for the third mode of vibration, it is how much? F3 is equal to 3 times F1. In general, what I can write? In general, okay, the modes of vibrations are said in the ratio F1 is to F2 is to F3. So this is definitely 1 is to 2 is to 3. Okay, you can proceed. Yeah, definitely. If it is for F4, it is 4. Okay, so 1 is to 2 is to 4, 3 is to 4 is to 5. You can go like this. Okay, so these are all about the first 3 modes of vibration formed on a stretched string.